We're also going to use our ideal gas law to calculate molar mass and density. So when we're reading this problem, we see what is, alright, I just lost my pen, there we go. What is the molar mass of a gas if 8.11 grams of it occupy 2.38 liters at 109.1 kPa and 10 degrees Celsius? So grams here is a mass, liters is a volume, 109.1 kilopascals is a pressure, degrees Celsius is a temperature. Then we change that to Kelvin. Now molar mass, we need to know the unit, and the unit for molar mass is grams per mole. Alright, so we have grams here, but we need moles. So if we notice that PV equals nRT, we can find moles. Okay, so if we plug in and solve for moles, we end up with PV over RT. So our pressure is 109.1 kPa. Our volume is 2.38 liters. We're going to divide that. Now our R value, we're using kPa, so our R value is 8.314. Okay, so let me just jot that down. And then our temperature is 283 Kelvin. So when you solve this, you end up with 0.110 moles. So if the molar mass is grams divided by moles, grams per mole, then we can just take and do 8.11 grams divided by 0.110 moles, and you end up with 73.5 grams per mole. So if you know what the unit is, that tells you what the formula should be. Okay, so the unit is your big clue here. Now some of you may like dimensional analysis, and I will do that in a separate video so that you can watch that and it won't confuse anybody. Alright, next example. What is the density of a gas at STP that has a molar mass of 44.0 grams per mole? Alright, so density is mass divided by volume, and that formula is on your reference packet on page 3. STP, alright, standard temperature is 273 Kelvin. Standard pressure we get to pick because they don't tell us one way or the other. I'm going to pick 1 atm because I like using ones in my math. Now 44.0 grams per mole is our molar mass. Okay? So we're going to have to use that some way to figure out moles. Okay? R value is going to be 0.0821 liter atm per mole Kelvin. Okay? So we are going to need to get moles so that we can cancel this guy out. Okay? Everybody with me? Alright. Now what we don't know here is volume. So we got a couple of things that we can do. We can work through this formula in lots of different ways. The easiest way, guys, is to set up a dimensional analysis problem. Okay, that's just going to be the easiest thing to do. Now for this problem, I could show you a bunch of different ways to rearrange all of our formulas. We have density equals mass over volume. We have PV equals nRT. Somehow we've got to get molar mass in there as well. The easiest way to do this, guys, is to use dimensional analysis. Alright, I said I would show you dimensional analysis in a separate video, but I'm going to go ahead and show it to you now because it's just easier. If density is mass over volume, then that means that my units are going to be grams over liters. Okay, mass over volume is grams over liters. So when I look at all of these values, I see that I have 48.0 grams per mole. Now that translates, when you write this as a fraction, as 44.0 grams per 1 mole. And you guys have seen this 100 times, right? So we can start here, okay? We want to keep grams on the top, but we need to cancel moles. We also need to have liters on the bottom. So if I look at this R value here, I can write this R value in two ways. I can either write 0.0821 liter ATM over 1 mole Kelvin, or I can flip that, okay, because this is it's basically a ratio, okay? So I can actually take and flip this around, which is what I want to do here, okay? Now I'm going to make a giant fraction, okay? So if I put 1 mole Kelvin on the top of my fraction and 0.0821 liter ATM on the bottom of my fraction, then my moles here will cancel. Okay? Now I have grams on the top, I have liters on the bottom. I need to cancel Kelvin and ATM. So if I do one more fraction, if I cancel Kelvin, I need Kelvin on the bottom. So I'm going to put my temperature on the bottom. ATMs I need to cancel by putting ATM on the top. So Kelvin cancels, ATMs cancel. Now if I take all of my units out and I just look at numbers here, I see 44.0 times 1 times 1 over 1 times 0.0821 times 273. And I can put this into my calculator now, and I'm going to get a density of 1.96 grams per liter. And anytime they give you a molar mass and ask you to find a density, this is what you're going to set up and do. You're going to set up the molar mass. You're going to put your R value on the bottom with the flipped units. You're going to put your pressure on the top and your temperature on the bottom. So let's look at one more example. Hydrogen sulfide gas occupies 278.2 milliliters at 26 degrees Celsius and standard pressure. What is the mass of the hydrogen sulfide? Alright, so milliliters, that's our volume, but we need to make that be liters, so it's 0.2782. You just move your decimal point 3 places. 26 degrees Celsius, that's our temperature. We need that in Kelvin, which is 299 Kelvin. Standard pressure, we're going to say is 1 ATM again, because I can pick. Now mass we want in grams. Alright, now, why is it important that we know this is hydrogen sulfide? Well, if we know that hydrogen sulfide is H2S, and you get that from using the charges on your periodic table and flipping them, then we know that the molar mass, okay, 1 mole is 34.086 grams. Now remember, when you write a molar mass, you can put that in a fraction as 34.086 grams over 1 mole. So we're going to use this, okay? So I'm going to use this to start my dimensional analysis. So 34.086 grams over 1 mole. Now I need to cancel everything here because I only want grams as my final unit. So for moles to cancel, I have to use my R value. Okay, and because I used ATM here, my R value is 0.0821 liter ATM over 1 mole Kelvin. So if I put my 1 mole times Kelvin on top, I put my 0.0821 liter ATM on the bottom. Okay, so notice what happens. My moles cancel. So now I need to cancel Kelvin and liters and ATMs. So to cancel Kelvin, I'm going to put my temperature on the bottom, and that'll be 299 Kelvin. Okay, so that guy cancels. To cancel my liters, I want that on the top. So I use 0.2782 liters. Okay, and now I want to cancel my pressure by putting it on the top also, which is 1 atm. So, again, we notice that our units are all canceling. So now, when we pull out all of our numbers so that we can do our math, we get 34.086 times 1 times 0.2782 times 1 over 1 times 0.0821 times 299. Put all of that in your calculator. Make sure you use your parentheses in there. Let's see. Let me calculate that real quick. You end up with a mass of, whoops. Well, where's my pen? Sorry. 0.386 grams. Now, while I'm showing you dimensional analysis, let me just go back to that molar mass problem. All right, so if we know that the molar mass we want in grams per mole, we can start with 8.11 grams. Now, that's just over 1. Okay, anything over, anything can be made into a fraction over 1. So we do need moles on the bottom. So my R value has moles in it. So if I use 8.314 liter kilopascals per 1 mole Kelvin, I now have grams over moles. So now I need to cancel everything else. So if I cancel liters and kilopascals, those guys are going to go on the bottom. So 2.38 liters and my 109.1 kilopascals. And then I need to cancel Kelvin by putting Kelvin on the top, so that's 283 Kelvin. Alright, so notice that liters cancels, kPAs cancel, Kelvin cancels. So when you look at this, you pull all of your numbers out. Let me pull the page. Here we go. Pull all your numbers out, you get 8.11 times 8.314 times 283 divided by 2.38 times 109.1, and you will end up with the same answer of 73.5.